Bridging platform engineering and observability, empowering developers with insights. My name is Kasper. I'm a developer advocate at Zero, KubeCon, CloudNetCon co-chair, former co-chair, CNCF ambassador, Golden Kubesnot, and all things around organizing meetups and conferences here in the Nordics. So let's get started. The TLDR for this talk is really that OpenTelemetry is standardizing telemetry collection, Perseus is standardizing dashboarding, and applying platform engineering principles to observability, we can transform it from an afterthought into a seamless, scalable, and developer-friendly experience. So back in 2019 at KubeCon, CloudNetCon in San Diego, Brian Lyles talked about the complexity of Kubernetes and really how we needed as a community to find the Rails moment of Kubernetes. And I think that really resonated quite a lot with me. And I think to some extent or to some degree that platform engineering is now enabling the Rails moment for Kubernetes in many organizations. And as Kubernetes was really the catalyst, platform engineering really took it further, and we started to build internal developer platforms that gave developers golden paths, the self-service experience, opinionated workflows, and guardrails. And the goal was really simple, right? It was about making it easy to build, deploy, and scale application without requiring deep infrastructure knowledge. So platform engineering introduced principles like the modularity, paved paths, strong APIs or clear APIs, and thinking of platforms as products, not just scripts or clusters. And that shift really enabled us to move faster and change really the developer experience entirely. And yet, when we look at observability, it hasn't followed the same journey. In many organizations, developers are still left to figure it out on their own. They write custom instrumentation, wire together logs, metrics, and traces manually, and hope for the best. There's no golden path, there's no consistency, and no self-service, and observability is often an afterthought rather than part of the platform itself. And then when something goes wrong, the mean time to recover is long and it's frustrating, and it's really not how modern observability should work. So for years, we talked about the three pillars of observability: metrics, logs, and traces. But in practice, those pillars were built on separate foundations. Different tools collected different signals, and they didn't speak the same language. Developers had one browser tabs for logs, one for metrics, and one for traces. And we were really relying on humans to correlate across these different signals. It's error-prone, it's slow, and it's frustrating. And when systems grow in complexity, this only gets worse, right? And the thing is really that we don't have a metrics problem or a tracing problem. We have a systems problem. And this fragmentation is leading to multiple challenges in this space. The complex query languages. Different systems rely on different query languages, making it really difficult to unify insights. Vendor login restricts flexibility and creates barriers to switching tools rather hard. Metadata inconsistency across platforms results in unreliable correlations. And due to this high complexity, many teams avoid instrumenting altogether, leading to gaps in visibility. And with no unified insights, troubleshooting remains slow and inefficient, forcing engineers to manually piece together information across disparate systems. But it doesn't have to be that way. What if we treated observability the same way we treat infrastructure? So just as Kubernetes, we need to find the Rails moment of observability. A shift is happening. It's a shift toward correlation. We're moving from isolated signals to correlated insights. Instead of treating telemetry as scattered data points, we are starting to connect them to see traces tied to logs, logs linked to metrics, and everything pointing to real context. That shift is what turns observability from noise into understanding and allows us to reconstruct the chain of events quickly when an incident occurs. And that shift is only possible through standardization. Just like Kubernetes gave us a consistent way to manage infrastructure, OpenTelemetry is doing the same for telemetry. It's open, it's vendor neutral, and it's quickly becoming the default. So now vendors can fight further down the stack, and you as an end user can much easier choose between the different vendors because now the collection part is standardized. As you can see in this image, OpenTelemetry is handling or providing instrumentation through SDKs, there's API specs, there's all kinds of different things there. And then there's the OpenTelemetry collector, which is really all about receiving, processing, and exporting telemetry data. And it also includes a transport protocol for how to transmit telemetry. So all of this is standardized, and vendors are now fighting around analysis and storage. But OpenTelemetry is more than just a library. It's a movement toward better observability. one agent to rule them all, one consistent set of APIs and conventions, and a community that's building the foundation of how modern systems are observed. This is the Rails moment that Kubernetes found with platform engineering, and now OpenTelemetry will be the Rails moment for observability, at least to some extent, and it's already here. In fact, OpenTelemetry is the second largest project in the CNCF by contributor count, and last year had more PRs plus issues than Kubernetes itself. Let's take a closer look at what makes OpenTelemetry so powerful. Well, first, it lets you instrument once and use everywhere. You don't need to worry about which backend you're sending your data to, whether it's Prometheus, it's Dash0, or something else. You just collect once and then you choose your destination later. And the second is really also about this, that we are now separating telemetry generation from analysis. This is huge because this means for you as a developer can now focus on like providing the right insights out of the code and then worry about which vendor you'll choose down the road because it's all standardized and all the vendors are building on this standard. Also, it makes software observable by default. Libraries are now shipped with instrumentation out of the box. You deploy your code and the traces are already there without additional effort. It's so powerful. And then, of course, it improves how we use telemetry. So that's all great, but doesn't it? But how do we make it accessible and easily accessible for our developers? I think that you can really think about it. It's not really OpenTelemetry is not just a tool. It's more like a platform to some extent, and that means we can apply some of the same principles that we do for platform engineering to observability. And here's just some examples that self-service. It's really about the auto-instrumentation that you can do in that I'll show you in a second. Semantic conventions is really how we are defining explicit APIs, and we also, of course, have the specifications of how to do everything. Golden paths, observability built in, using auto-instrumentation, using all of these conventions. Pipelines in the collector will give you a lot of modularity there. And of course, we should treat observability as part of as a product and provide the right documentation and support for our developers internally. So the OpenTelemetry product also comes with an operator, and I will, in this talk, only focus on the instrumentation part. And that is really what gives you like self-service, or you as a platform engineer can provide your developers with this self-service experience of getting traces and metrics and logs out of the box without them doing anything in the code. This works for Go, Java, Node, Ruby, and Python. And you define this instrumentation resource, and then it will automatically inject whatever instrumentation is needed into the pod itself. But it doesn't stop at instrumentation, right? We also need to visualize and get the data to some place where we can actually see it live. And this is where Perseus come in. It's an open specification for dashboards. It's a CNCF sandbox project. And it allows you to define dashboards as code. You can use YAML, you can use Go, and you can use Q. But the cool thing is really that dashboard as code allows you to commit them into Git along with your application code itself. You can also, as a platform engineer, build abstractions on top of this and really scale your observability. It also comes with an operator where you really define like a Perseus dashboard, and you will apply that into a cluster. So I want to do a short demo. I will show you a to-do Java application. It's written in Java, of course, and then it will use auto-instrumentation using the OpenTelemetry operator, collect the data with the OpenTelemetry collector, and we'll send that to Prometheus and Jaeger. And then I'll show you Perseus and the operator there. All right, let me show you what I have in a cluster now. I have a few things. I have the OpenTelemetry operator. I have some collectors running. I have Perseus server, and then I have the two to-do applications. So what I want to show you is the code that I have running. So I have this Java application. It's a to-do Spring application, and what you should notice in here is that there's no specific thing around instrumentation in this one. So this one is not that interesting, so we'll have a look at the controller instead. You can see, again, it's a REST controller. There's no specific instrumentation within this, which is quite nice. So in order to do this, we will instrument this using the OpenTelemetry operator and the instrumentation resource I told you about before. So we define some endpoint or an endpoint where the collector is running. So we'll send our information to the collector. From the collector, we will forward that into Prometheus and Jaeger for tracing. We can do like different configuration for sampling and a different configuration for the different languages, which is quite nice. So I will just quickly deploy this one or apply this one. And what we should see now is that nothing really happened because you need to opt in. So and the way you do that is that you can edit the deployment, and you need to add let me find the labels. So in the pod spec down here, we need to add an annotation. And we tell it to inject, not Go, but in this case Java. We point it to the namespace and the name of the instrumentation resource. This is what I just showed you before. So we apply this, and then in a second we will see that, let me just clear this, that now we actually have a to-do Java application running. And if we take a quick look at that, we will do describe pod. You can see that the operator has now added some OTel specific environment variables, and then it's actually also adding like Java tool options, and it's running this Java agent along with the application itself. And the Java agent is coming in through this init container that we have up here, which is also managed by the OpenTelemetry operator. So that's really how it works. So if we port forward this application, and we can send some requests to it. So in this case, it's a to-do application. I need to remember to go to the platform con this year, right? So I will just apply this. And that should have given us some information to look at. So if we go to Jaeger in this case, refresh Jaeger, we will see now that to-do Java application actually has this trace of the request that I just sent you. And we can inspect this, and you can see the different, you can see the duration, and we can go and see like insert, like this is the client span of the database call that is happening. So you can see all kinds of interesting information out of the box without touching the code at all. That's pretty nice. Last thing I want to show you, Perses. So Perses comes with this resource called the data source. You'll see it here. It basically defines where Perses can query the different metrics. In this case, it's Prometheus. So we'll just apply this. And then we will apply a dashboard. I will just show you it in a second. Cat Perses JVM dashboard. So there's a lot of YAML in here, but what it really does is about like defining different panels, time series charts, some queries, and then you lay them out in a grid as you saw down here, the different panels, and that's really how it works. So if we go to Perses, which is what we have right here, I'll just refresh. You can now see we have a JVM metrics dashboard, and some metrics is starting to come in. So that is really nice. You can see it's not really, that's not enough data yet, but there's some data that has already arrived, which is nice. So that's really the demo. All right, so let's recap. We created a Java application. We used the OpenTelemetry operator to use the instrumentation resource to automatically instrument the application, see the traces in Jaeger. We used the collector to collect this and send it, of course, to Jaeger, but also to Prometheus. And then we used Perses to visualize this using the dashboards as code. So the goal is really like observability as a paved path, right? With auto-instrumentation, everything comes out of the box, automated dashboards, and all of this should be possible with OpenTelemetry and Perses as it is today. And if observability is evolving, and it's evolving really, really fast right now. OpenTelemetry is standardizing how we are collecting telemetry data. So the days of fragmented data are numbered. Perses is standardizing dashboarding. And by applying platform engineering principles, we can transform observability from an afterthought into a seamless, scalable, and developer-friendly experience. Observability is a systems problem, not a tracing, logging, or metrics problem. And when we connect signals together, we empower developers to solve problems faster. So this was my talk. Thank you so much for listening in, and feel free to connect using any of the socials, LinkedIn, X, Blue Sky, etc. Thank you so much. Have a wonderful platform engineering conference.